Contamination Engineer. You know, we're going to have a lot of work to do. It's going to be a situation where we're trying to get ready for launch, but I'm going to make everyone around me take a moment to just be like, look at this. Like, can you believe that we're about to put it in the rocket? This is the last time we're going to see it. You know, look at all the work we've put into it, and just be so elated and nervous at the same time. And I think it's bittersweet because everyone enjoys working on it so much that it's hard to say, wow, this has been such a big part of our lives and it's gone now, but you take those lessons and bring it on to the next thing you work on. Like, I feel so fortunate that I have a job where I can share this with other people and get them excited about it too. So we try to like bring other people into the knowledge we know. My name is Elaine Stewart, and my title for my position at NASA and working on the James Webb Space Telescope is as a contamination engineer. So we are actually responsible for maintaining the cleanliness of our optics, which are the beryllium mirrors, or maintaining the coatings that are on the telescope, and ensuring that once we launch, the telescope will be able to observe the targets that we are trying to see. So we pretty much have requirements for how much particulate and how much fibers we can get on it, or the molecular, so that would be kind of like thin film that it can accumulate on it. So we're constantly tracking and inspecting and cleaning the mirrors if we need to, in order to make sure that they are at the pristine level when they launch, and we'll be able to observe all of our targets. My parents are both chemical engineers, and that was prevalent in my family. And I had a passion for calculus and science, so I decided to pursue chemical engineering. I actually ended up applying to a one-time internship with NASA at the Kennedy Space Center. I had always loved the idea of space. I had just never really thought that that was something that I could work in, and I was accepted, which I was so incredibly excited about. And I spent the summer at Kennedy working on a mission that was going to the moon to actually analyze what is in the lunar soil. So I was able to see some launches. I was able to get my first real hands-on engineering experience, and I was drawn to continue to work at NASA from the passion of the people that I worked with, just the excitement that I got about everything I was able to do. So I applied, and I was accepted at Goddard. The first project that I was put on was the James Webb Space Telescope, which I could not believe. Something that excites me the most, and like what I would really love to happen, is something unexpected, that we're trying to observe one target and we say, oh my gosh, like, what is this? We have no idea what this is. Because I know Hubble had looked at like a point in the sky where there wasn't anything to observe, and they found like, look, there's all these galaxies in this one area. Hubble is much closer, and we were able to send astronauts up there, and they had servicing, some modifications they needed to make. But the James Webb Space Telescope is 1,000,000 miles away, so we are not able to go up and make any servicing or make any changes or anything like that, which is why we need to ensure everything is perfect on the ground. The work that we've done on James Webb has already impacted humanity. So there is a sensor that was used with the creation of the James Webb mirrors, and now it's actually being used for diagnosing diseases in human eyes. So something that NASA does is they'll take technologies that they've developed for space and find applications for here on Earth. You know, science and religion and everything, you don't need to pick one or the other. I think that there is a middle ground. And while some things are difficult to explain, the further we develop our technology, the more we learn, and the more that we're able to realize, you know, maybe this is rooted here, or maybe this isn't rooted here. So I think it could be a combination between Big Bang and some things that we can't explain quite yet, but maybe we will be able to one day. I think that there's lots of things that you can't explain. I think lots of things can be rooted in science, but what excites me the most is that there's so much that we haven't even explored yet, and it blows my mind to think about like what's been discovered in the past decade and think about what's going to happen next decade. You know, we're going to have a lot of work to do. It's going to be a situation where we're trying to get ready for launch, but I'm going to make everyone around me take a moment to just be like, look at this. Like, can you believe that we're about to put it in the rocket? This is the last time we're going to see it. You know, look at all the work we've put into it, and just be so elated and nervous at the same time. And I think it's bittersweet because everyone enjoys working on it so much that it's hard to say, wow, this has been such a big part of our lives and it's gone now, but you take those lessons and bring it on to the next thing you work on. Like, I feel so fortunate that I have a job where I can share this with other people and get them excited about it too. So we try to like bring other people into the knowledge we know. My name is Elaine Stewart, and my title for my position at NASA and working on the James Webb Space Telescope is as a Contamination Engineer. So we are actually responsible for maintaining the cleanliness of our optics, which are the beryllium mirrors, or maintaining the coatings that are on the telescope, and ensuring that once we launch, the telescope will be able to observe the targets that we are trying to see. So we pretty much have requirements for how much particulate and how much fibers we can get on it, or the molecular, so that would be kind of like thin film that it can accumulate on it. So we're constantly tracking and inspecting and cleaning the mirrors if we need to, in order to make sure that they are at the pristine level when they launch, and we'll be able to observe all of our targets. My parents are both chemical engineers, and that was prevalent in my family. And I had a passion for calculus and science, so I decided to pursue chemical engineering. I actually ended up applying to a one-time internship with NASA at the Kennedy Space Center. I had always loved the idea of space. I had just never really thought that that was something that I could work in, and I was accepted, which I was so incredibly excited about. And I spent the summer at Kennedy working on a mission that was going to the moon to actually analyze what is in the lunar soil. So I was able to see some launches. I was able to get my first real hands-on engineering experience, and I was drawn to continue to work at NASA from the passion of the people that I worked with, just the excitement that I got about everything I was able to do. So I applied, and I was accepted at Goddard. The first project that I was put on was the James Webb Space Telescope, which I could not believe. Something that excites me the most, and like what I would really love to happen, is something unexpected, that we're trying to observe one target and we say, oh my gosh, like what is this? We have no idea what this is. Because I know Hubble had looked at like a point in the sky where there wasn't anything to observe, and they found like, look, there's all these galaxies in this one area. Hubble is much closer, and we were able to send astronauts up there, and they had servicing, some modifications they needed to make. But the James Webb Space Telescope is 1,000,000 miles away, so we are not able to go up and make any servicing or make any changes or anything like that, which is why we need to ensure everything is perfect on the ground. The work that we've done on James Webb has already impacted humanity. So there is a sensor that was used with the creation of the James Webb mirrors, and now it's actually being used for diagnosing diseases in human eyes. So something that NASA does is they'll take technologies that they've developed for space and find applications for here on Earth. You know, science and religion and everything, you don't need to pick one or the other. I think that there is a middle ground. And while some things are difficult to explain, the further we develop our technology, the more we learn, and the more that we're able to to realize, maybe this is rooted here, or maybe this isn't rooted here. So I think it could be a combination between Big Bang and some things that we can't explain quite yet, but maybe we will be able to one day. I think that there's lots of things that you can't explain. I think lots of things can be rooted in science, but what excites me the most is that there's so much that we haven't even explored yet, and it blows my mind to think about like what's been discovered in the past decade, and think about what's going to happen next decade. We're going to have a lot of work to do. It's going to be a situation where we're trying to get ready for launch, but I'm going to make everyone around me take a moment to just be like, look at this. Like, can you believe that we're about to put it in the rocket? This is the last time we're going to see it. Look at all the work we've put into it, and just be so elated and nervous at the same time. And I think it's bittersweet because everyone enjoys working on it so much that it's hard to say, wow, this has been such a big part of our lives and it's gone now, but you take those lessons and bring it on to the next thing you work on. Like, I feel so fortunate that I have a job where I can share this with other people and get them excited about it too. So we try to bring other people into the knowledge we know. My name is Elaine Stewart, and my title for my position at NASA and working on the James Webb Space Telescope is as a Contamination Engineer. So we are actually responsible for maintaining the cleanliness of our optics, which are the beryllium mirrors, or maintaining the coatings that are on the telescope, and ensuring that once we launch, the telescope will be able to observe the targets that we are trying to see. So we pretty much have requirements for how much particulate and how much fibers we can get on it, or the molecular, so that would be kind of like thin film that it can accumulate on it. So we're constantly tracking and inspecting and cleaning the mirrors if we need to, in order to make sure that they are at the pristine level when they launch, and we'll be able to observe all of our targets. My parents are both chemical engineers, and that was prevalent in my family. And I had a passion for calculus and science, so I decided to pursue chemical engineering. I actually ended up applying to a one-time internship with NASA at the Kennedy Space Center. I had always loved the idea of space. I had just never really thought that that was something that I could work in, and I was accepted, which I was so incredibly excited about. And I spent the summer at Kennedy working on a mission that was going to the moon to actually analyze what is in the lunar soil. So I was able to see some launches. I was able to get my first real hands-on engineering experience, and I was drawn to continue to work at NASA from the passion of the people that I worked with, just the excitement that I got about everything I was able to do. So I applied, and I was accepted at Goddard. The first project that I was put on was the James Webb Space Telescope, which I could not believe. Something that excites me the most, and what I would really love to happen, is something unexpected, that we're trying to observe one target and we say, oh my gosh, what is this? We have no idea what this is. Because I know Hubble had looked at a point in the sky where there wasn't anything to observe, and they found look, there's all these galaxies in this one area. Hubble is much closer, and we were able to send astronauts up there, and they had servicing, some modifications they needed to make. But the James Webb Space Telescope is 1 million miles away, so we are not able to go up and make any servicing or make any changes or anything like that, which is why we need to ensure everything is perfect on the ground. The work that we've done on James Webb has already impacted humanity. So there is a sensor that was used with the creation of the James Webb mirrors, and now it's actually being used for diagnosing diseases in human eyes. So something that NASA does is they'll take technologies that they've developed for space and find applications for here on Earth.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I am going to make a lap around
Oh,
this
hi,
room because
Jimmy.
I haven't seen this
You're
yet.
dancing.
I'll catch you guys in a little bit. I'm gonna go on.
Nice to meet you, Jim.
Yeah,
That's the way. Great dance.
Yeah.
It's all about exploration.
Here we go.
I was already here.
We have a dancer over there. Yeah.
Alright, I'm gonna refresh my screen and hope it comes
Well,
up.
yeah,
You can start when you want.
A minute ago, so I had to respawn.
Be able to get back in with that. You too.
I'm not the greatest avatar. for eyes that are
Oh, cool.
so good at catching movement.
Ashley, you're ready? Go.
Hi, everyone. Welcome to Unfolding the Universe, a NASA James Webb Space Telescope VR experience.
Cool.
I'm Ashley Zelinskie, and you are currently standing in the Earth Gallery of Unfolding the Universe. As you walk around the space, you'll see a bunch of art from different artists that I worked with in a show that was featured at NASA Goddard a few years ago. The group of artists was lucky enough to go and visit the James Webb Space Telescope while it was at Goddard. We actually got to see it in the clean room, and it was absolutely gorgeous. So we were able to see the James Webb Space Telescope and then make art about it. So that's the art that you're seeing in the gallery today, is all the gorgeous artwork from all these different artists that were lucky enough to see the James Webb. In a bit, we're going to just walk around the gallery, check out the artwork, and then we're going to move into the Sky Gallery. And the Sky Gallery is my own virtual reality creation that I did in coordination with the James Webb Space Telescope team. And it was brought to life by the wonderful people at Metaxu Studios. They're amazing VR designers and architects. And so we will do a turnabout this gallery and then go meet with Elaine Stewart for her talk. And she's going to be in the Sky Gallery giving a talk, and she is going to tell us all about aerospace and contamination and how they kept the James Webb Space Telescope clean as a whistle while it was here on Earth and prepared it for launch. So I will let you go and take a look at the gallery, and I'll see you in the Sky Gallery.
Hi, I'm Jedidiah.
Awesome. Thanks, Ashley.
All
right.
But I'd say you're pretty. That's.
You know, if you have any questions.
I mean, just in like a perspective in here in the VR,
This is so cool.
the mirrors were really big. That is.
Are you guys finding it easy to navigate?
I feel like pretty close.
Yeah, definitely.
Getting used to it.
Okay.
With the headset.
Yeah, it gets really easier when you use, if you have your mouse, you can use it to kind of rotate. You point the cursor and you use it to rotate left or right.
Check out Jimmy.
I'm still walking the wall, so.
You can change your avatar. It's kind of cool.
I tried that and my screen went blank. And
Oh.
so I'm sticking with this, but I've got a MacBook Pro. I mean, there's plenty of power to run this thing. I don't know what to do.
Yeah, mine's an older MacBook.
Cool. Okay.
Mine's
All good.
7 years old.
Yeah, mine's brand new, and that's why it's not putting out what I need. I don't know.
Oh, I opened a link. What's going on here?
Oh, everybody's over here. Where's the link?
Right.
Cool.
Front. Well, it's the
like just the three, just the red lines and
Dancing guys in and out.
But I was really taken back when I.
Am I going to
Hey,
disappear?
Stu Crew.
Pretty amazing. The sci-fi kid made me very, very happy.
Definitely a good one. It works. It's very, very cool.
Hello,
And
Scotty
now creating
Rocket.
art in it too, being able
I'm
to
trying.
figure out how to sketch in it in a 3D space and move everything around.
Oh, are you going over into the other space
Pretty
already?
awesome.
Well, it says I'm blocked, so I got to figure out
I'm
how
using,
to
I think it's
unblock that.
graphic sketch.
Let's try this again.
Graphic sketch. Let me see if I can find it.
Oh, what is that?
Over here.
You can't see my thing, can you?
No.
Okay, good. It's gravity sketch.
Gravity, yes, of course. Gravity sketch.
Yeah.
It's over here. Yeah, that's a good one.
So where's this?
That's really great.
Yeah. Have you tried
Hello.
tilt brush?
How are you?
No.
Yeah, tilt brush.
I'm Jedidiah.
Tilt brush?
George, how you doing?
I'm doing great.
It's
Well,
actually
welcome
now
to the
open
space,
source.
George. Isn't this awesome?
Oh, really?
Yeah, it's pretty cool.
Yeah.
Have a look at it.
Well, I'm one of the artists here, and to your right, those are my 3 pieces for the show.
About the
Beautiful.
Thank
That's
you.
nice.
How did you find out about the exhibit?
Oh, now I'm curious.
I
think the
follow
thing I really liked
like
about
some
Gravity Sketch is
space
that I thought it
pages
was
on
just gonna
Instagram, and
be kind of a
one of them
toy,
just posted
you know?
them, and I just like, ooh, this
But
sounds pretty interesting,
there's a
especially because
separate
it said like
server you can
VR.
put all your
So I just kind of wanted to check it out.
and you can
Oh,
drop
cool. Well,
in
welcome.
textures
This
and
is
images
kind of
and
new
take
to me
them
too, and I'm
in
just really
VR,
enjoying it. I
that's
feel like
really great.
I can kind of explore the whole time.
Yeah, this is
Trying to make sure
this is a
my
pretty cool
hands don't do
experience.
weird stuff here.
Yeah, and there's going to be a lot happening because there's going to be a talk pretty soon. I believe at about
What time is
8
it?
o'clock
It's 20
or
okay,
7:30. Yes,
Time gets weird in here.
we're gonna go to the other gallery, the Sky Gallery, which is amazing, and that's where it's going to be a talk.
Okay, nice.
Yeah. With Elaine, who's one of the engineers at Goddard, that she worked on the telescope.
Okay, nice. Yeah, I heard her briefly talk about that real quick. So looking forward to that too.
Well, welcome to the space. If you have any questions or anything, feel free to ask. There's a lot of artists walking around. There's one of them. Hi, Brandi. She's right there behind us.
Hi.
Yeah, introduce yourself
Hi.
here.
Hello, Brandon. Hi, George.
Hi, Brandi. How are you?
Doing all right. Oh, yeah, we both have hands.
Yeah. Yeah, this is my first time. I've had a VR for the longest time, but I think it's the first time that I used it, to be honest.
Oh, really?
Yeah, so it's pretty cool to see like all this space stuff.
Yeah, this stuff's been pretty fun.
Yeah.
I don't know if we are. I think we are. Are we? When do we move over to the sky?
7:30 is what I believe it was. So I probably head over to the group and see.
Yeah, the downside is not being able to really get a sense of time in here and having to check.
And feel like you're missing something. So I'm gonna wander around and see what they're discussing.
Jimmy, may
Hello,
I bothering
Astrosphacer.
you? Hi. May I bothering you and ask you to change
How's
your
it going?
avatar?
Oh, is it bothering you?
Pretty good, pretty good.
Well,
I'm
it's
just,
I know.
for the first time, and
No,
I'm
it's
sort of
okay, but I
getting,
know when we do
I
the.
thought we were all kind of
talk,
avatars,
it
so like,
doesn't stop
maybe I'll
moving.
put my name on.
It doesn't stop moving.
Yeah, no, it's cool. I just learned how to create one
can be
today.
pretty
Ashley showed me how to do it.
It's
and
very
a bunch of us how to
eye-catchy.
do it. So, but isn't this space amazing? It's absolutely exciting to cruise around. Is this your first time in a VR space?
It is.
Okay. It's okay. Well, there is many. It's just the one you're using is kind of a animated GIF.
Yeah. Are you finding it easy to navigate? Because it's easier with the mouse. You can kind of rotate freely with it.
Hello, how are you doing?
Hello, Nick. Hello, Mom.
Sorry,
and
I think I was muted there. Doing pretty good over yourself.
Hey, what's up?
Doing great.
If you have any questions, I'll be
Mom and Dad.
Excellent here. Are you an artist here or
No,
just like a guest?
I'm going to be giving the talk tonight. My name's Elaine.
Oh, Elaine, yeah, I just saw you not so long ago. Oh, okay, cool.
Oh, this is Brandi. She's one of the artists.
So are you using a set of the VR glasses to move around the space?
Yeah, I am. It's like one of my first times using this, so I'm still kind of getting like the hang of it. But it's everything's pretty cool.
All sorts of art.
Yeah, I haven't tried actually being in the space with the goggles on yet, but I definitely want to.
Yeah, that's the thing that like caught my attention. I'm like, ooh, space and VR. I'm very curious about this, so that's why I'm here.
Absolutely.
Camera one.
Some people might be but I'm not 100% sure.
Responding,
But
but
also
you've gotten one email
quilting
from
over in
someone
the
who
corner there's
didn't
what
get
Sue did.
the hub's
There's
code
watercolor.
message that went out to
I
everybody to
tattooed and
spam, but that's
painted.
the only complaint I'm seeing via email.
Okay.
There's some installations in here.
I mean, again,
Some
last time we did
graphic
like
design
tickets
work.
and it was like
A lot of like
mostly
all
no
walks.
shows.
It's
So
very she did a very good job.
you know,
Very eclectic.
it's possible we may find that we want to do even more than 50 tickets because there's that many no shows.
Yeah.
But this is way better than last time. There's people actually here looking and talking, and it's really cool.
Dig the pattern on your robot
Yeah,
there.
it is. And Carlos is doing some really cool
If you do have any
shots
questions
there
about anything, or
on
if
the-
you're
on
looking
the
around at the
live
work,
stream,
there's
so
a
it's-
there's the
key
cam. Hi,
right
Cam.
there with all of
Oh,
the
it just
different
passed
artists
us.
on it, so you know where you're going.
I'm gonna chase the camera.
Oh, sweet. Good.
Oh, there's another one. Hello, hi.
Yeah, there are two cameras tonight.
Yes.
Be careful. Be present well.
Yes. Fix my hair.
Smile.
This is all
Oh,
based
we
on the
have
James Webb Telescope.
Looks like you are in a headset. How is it for you?
It's pretty cool. It's my first time
I'm
using
not sure.
the
What
one of my
part
first
were
time
you
using the
looking for?
headset, so I think everything's pretty cool in the headset.
Oh, wow. Okay.
Oh yes, yes.
So you are with the
Elaine
Quest
here is
2?
going to be speaking.
What was that?
Oh, what headset are you using?
The Quest.
Yeah, the Quest.
The Quest.
The white one.
Yeah, exactly. Yeah, the white one.
Sorry, I think I got a little bit of
Cool,
lag. I
wow.
apologize.
That's great.
That's okay.
I mean,
Yes.
usually
How are
I'm
you doing,
also with
Walter?
VR, but
I'll
I'm
be giving a
here,
talk
so
in just a
actually I
short
designed
while.
the
We're
space
going to
here.
spend a bit more time in
Oh,
the
really?
art
I'm
gallery
very
here, and then we'll
familiar with
move
VR, but
to the other
I
section
know
of the
what it
VR
is to be
space.
in this space in the headset. So
Okay.
Okay, that's
Thank
cool.
you.
and you like it?
You around.
yeah, I mean, there we go.
Yeah, feel free.
Thanks, Walter.
Yeah, all of this
Thank
is like
you.
new to me,
Some
so I'm
incredible
like,
artwork to see.
yeah, I
if
just
you
saw an ad on
wander
Instagram.
around.
Not an ad, like a space
a
page that I
little
follow on
map,
Instagram,
too,
like posted
that
about
will show
this,
you
and I
exactly
saw that
where
it
you
was like
are.
VR, so I'm like, ooh, yeah, let me take a look at this. I definitely want to check it out.
You're one of the lucky one because I think there was a lot of people trying to get their tickets. So we can only, host 25 people in a room at the same time. So you're the lucky one.
Okay, that's why. Yeah, because I tried sending my brother, because my brother's into space as well, and I tried sending my brother the link, but it wasn't like he wasn't able to register anymore, and he was gonna ask one of his buddies to let him borrow his headset for it.
Well, I mean, if there is still, I mean, no, it's almost starting. You can try to have him on board if he's connected.
Okay. Yeah, I don't think he's.
Oh, it's almost starting, huh?
Yeah, so we
Is this where we click?
what's the timing? I mean, they're gonna announce the timing as it goes. So
Yes, this is where you would click once the talk begins, but it hasn't started yet, so just sit tight.
have you look around? I mean,
Yeah, I looked around. I was got here pretty early, and I just looking around, looking at the paintings. It's pretty. I think it's pretty. I'm pretty amazed, to be honest, about everything. Everything was cool.
When she says departure, she means the second room, right?
Yes.
Yep.
Okay. I just want to make sure.
Okay, we're going to move over.
No, I
If you
don't.
want to follow me.
Awesome. Hey there. We're gonna start moving over to the other side of the gallery. If you'd like, go to the second room. If you want to follow me.
Yellow pixel road over to the next area.
And then when it's green, you let it go. You're gonna
Oh, okay. Wow, you just made my experience way much way much
guess
easier.
to
I
the
was
right.
struggling with that.
Because when you move around with the analogic stick, it can make you a bit dizzy.
Crew.
The jump is a bit better.
Yeah.
You want? We're gonna start moving over to the other
100%.
gallery.
Yes, please.
Are we making a move?
We are. We are getting ready.
Yeah, I see people moving in the same direction here. So let's move.
Over that picture. What do I need to do here? I'm inside this room now. Whatever. I'm gonna go check the other side. I might need to mute my. I'm getting some feedback here. Did you get everybody over there?
Yeah, it's not responding.
Okay.
Hello, everyone.
Hello.
How are you guys?
It's going well, thanks.
Smooth transition over?
Oh yeah, totally smooth. Actually, yeah, it's better than expected, honestly.
Can you guys hear me okay?
Mm-hmm. Yes. Yeah, you're good. Yep.
Okay, so now we're in the Sky Gallery space, so you guys can walk around. There's portraiture of the scientists that I interviewed that inspired this space, and if you walk up to their portraiture, it's interactive, so they'll speak to you the interviews. So
cool.
yeah, they're all the purple portraitures around the edges.
It might be helpful if
Yeah, I got it. Just follow me. Yeah, okay, they said yes. Okay, just follow us.
It might be helpful if we're not talking to.
Come on over.
You.
I just said
Where am I going now? Do I click on the other link here?
Perfect. Yep. Okay.
Inside. I'm inside.
Yes.
I'm confused.
Hi, Jorge.
Hey, what's going on, Scotty? How you doing?
There, are you trying to get to Elaine Stewart's talk by any chance?
I'll wait right here for you guys. Okay. So, there's the hover your cursor over the picture of the Milky Way or over the way.
Well, I'm inside the other room. Is that where I want to go? I'm just in the room now.
Yeah. Yeah, so I want to. Thank you. I'm still trying to clean it up, but yeah, thank you.
Yeah, mine wants to keep their name.
So there's two galleries. This is the Earth Gallery for the Nocturne.
Okay.
That way.
Elaine, can you hear me?
Space.
Yes. Yeah. Can you hear me, Elaine?
Just going around making sure everybody's getting it. There you go. Just follow that yellow.
Is everything all right here? Good. Matthew? Hello, hello. All good over here? Brandon, can you hear me? I have some sound issue.
Hey, Ashley. How about now?
Hey, Maggie, can you hear me?
Yeah.
Yeah.
I can hear you.
Yes, I can. Elaine, I can kind of see your bubble moving that you're trying to speak, but I'm not getting any sound from you.
Okay, let me try again.
I hear you, but you're cracking.
I'm not hearing Maggie either.
You can't hear me?
Maybe that's my fault for some reason.
Can you hear me now? I can hear you both.
I don't know why it would be. Hey everyone, so this is where the talk's going to take place, so cozy up, get a good spot. Hey Maggie, can you say something so I can test my audio? I'm not
Can you hear me
you.
now?
It's so weird.
Can you hear me?
I'm hearing the music, I'm not hearing people's voices
No,
in the
still
space.
not. Is it me or you?
The audio was very choppy.
Scotty Rocket, can you hear me? Or Jimmy?
I'm gonna disconnect from my AirPods.
Brandon, can anyone hear me?
I can hear you, Maggie.
Okay.
I can hear you, but the audio is very difficult to. It's very choppy.
Yeah, I feel like my audio is garbled. I think I should try to come back in maybe?
Not hearing anybody.
Okay.
Can you say that again?
Ashley, I can hear you.
It's really staticky, and I don't know if it's me or...
Ashley, I can hear you.
I can hear everybody else really well. I can hear connection.
There's lots of people in here. Oh, here's everybody.
I'll jump to the other place then.
Hi.
People here.
This is where everybody's at. Hello.
Mom and Dad, you want to come this way?
Jedidiah, can you hear me?
Jedidiah, can you hear me?
Hi.
I can hear you, Matt.
Somebody called my name, but I can't tell who it was.
That was Maggie. Can you hear me?
A little bit. Kind of. Oh, there you are. Hi, Maggie. Is that you?
Hi. Yeah, that's me.
Are we just waiting for people?
I think so.
Can you hear me okay?
Okay.
I just want to make sure that people can hear me.
Yes, I can hear you, Ashley.
Okay,
How is
here, there you
everyone
are.
doing?
Can you hear me? I can't hear
Yes.
you.
Can you not hear me?
I can hear everything else except you talking.
Okay.
I'm gonna reload again. I don't know why this is happening. I've reloaded a couple times.
Okay, we go.
Let's branch so that we know.
Yeah, we've got some issue, some sound issue. Everybody can you hear me, everyone?
Get along with the unknown. We are the moment.
Hey, Brandon,
We are the moment.
Jumbly.
Together.
Yeah, sound is not so good over here, isn't it? Hey, hello, Ashley. Can you hear me now? Not so good, is it?
Hello, Nicholas.
Hello.
Right, sounds like we have some. Walter is over here. Well done. That's
Yeah,
something.
I'm in the right auditorium, right?
Great. Yes, that's a good step forward. Although we have some sound issues, so everything is also. How are you doing, Elaine? Is the sound okay on your side?
Here, yes, you're coming. You're coming. So it's very broken up. I can't actually make out what you're saying. I'm not sure if you can hear me okay.
No, it sounds terrible. Oh dear. Okay. It sounds funny, isn't it? Alright, so we have sound issue.
Still nothing here. I don't know.
Can you not hear me either? Oh dear. Alright, what can we do?
Elaine is in this room over here, back behind this room.
Right.
So I didn't know if you've been here yet or not. Hanging out and waiting. If you follow that yellow in the air here, it'll take you over to Ashley's image of a Milky Way. And you can hover over that and click to go to the next room. Please feel free to take your time.
Brandon, this way.
They're working on a presentation here shortly.
So are these holes time holes or time warp? Oh, I see there.
Hey there. Hey, Brandi. I see there's one guy over there. I think they're having a little bit of trouble on the other side. It's like hard to hear anybody. It's like the sound is underwater. They're having some trouble. Did I say that right? I meant that they're having trouble in the other room, not that person is having trouble. I got you. Okay.
Some sound issue.
All right, can you hear me now, Ashley? No?
Brandon, is this the right place now?
I'm having trouble hearing. There's a lot of static. Can you hear me okay?
No, Brendan, yeah, I can hear you, but it sounds pretty bad, so let's try to mute as much people. So now. Yeah. Also, I know a lot of people have mute themselves, so maybe let's reload the game and let's try again. Yeah, one more time. Yes, hi, where are you watching? Can you hear me now?
Am I visible or audible?
Getting back into this room.
Alright, how do you want to go with this?
Oh, I've actually never gone to the other room yet, so I would not know.
Are you staying in this room?
Last time we did this, I was kind of here just in case anybody was asleep.
Got it.
So we could guide them, but I don't know. I think one of us should stay behind.
Yeah. Well, why don't you go in?
Where are we supposed to go?
I will. Thank you. I'm sorry.
Yeah.
to do this.
Oh, no, because you were here for the last time, right? So probably...
Hi, all.
Go in next time.
You're asking where to go?
Yeah, gallery? You didn't go in last time, so I'm just going to hang out there.
Conceptual engineers, they're interactive.
On the live stream, so I don't know.
They're the spy. Universe. These little pieces there, that's where the conflict
I think what's happening is they have me come, like, move it. And... Hey, Jim?
Up the screen to the left.
Jim? Oh, no, you're gone.
Hello.
Can you hear me? You go ahead, go in, and I'll hang out.
Great, good.
So,
Okay,
excuse me, where's the door that I'm looking for?
Maybe we should start now.
You doing okay over here?
I'm trying to go into the next presentation room.
Yes, come over here. You're welcome over here. Can you join me next to the big image here over here? Here. Can you hear me all right, Maggie?
Yes, I can hear you. Can you hear me?
Yes, I can hear you. Okay, so we have some sound issue, but
that's what's happening.
it seems we
Hello,
got
Nicholas.
Does it seem like it's on Elaine's part?
Was everything okay in the other room?
So let's.
It is shortly. I think there was some trouble with the audio in there, so they were trying to fix it. Yeah. Straight this way. You following?
How do I get out of the gallery? The Ashley gallery.
It's this one. Just roll I'm not sure if you have a headset or but if you roll over this Milky Way picture, it'll show you a pink link.
Hello, Ashley.
Hey everyone, we're just going to meet over by the slide presentation because we're going to be starting our talk soon.
Hello.
Can you still hear me now or not?
How's the big purple sky above it? We want to head over
No.
there. We're hoping to start soon. Let's head on down where that under that big purple sky.
And the closer you scoot up to the slide presentation, the easier it's going to be to hear Elaine speaking, because the music in the space kind of dissipates the closer you get to the stage and to the slide presentation. So don't be shy.
Okay. Okay. So how do I back out of this gallery? I was there before, but I couldn't get out of it.
Hey, Walter, are you
Yes.
asking? Hi, how are you doing?
Good, good.
You need to reach, you need to do, U-turn and to reach the space behind you.
But now I'm in the gallery. Now the gallery is what else is hard to do. I'm in the Ashley.
Is it white or black?
Hello, can you all hear me?
Sounds great.
Awesome.
Yes.
Hello, everyone, and welcome. I'm Maggie Masotti. I'm the social media lead for the James Webb Space Telescope. This is my 17th year on our mission, and what a year it's already been. When I first started on this project, there was no hardware. It was just, a vision, and I've been lucky enough to be able to watch the mirrors and instruments come together at NASA's Goddard Space Flight Center. We launched on Christmas Day 2021, and now here we are getting our telescope ready to do science. I wanted to give you a little intro to our mission and our connection with art. So Webb is a really big infrared space telescope, and to see the things we wanted to see, like the first galaxies that formed in the early universe, the telescope was given a giant gold-coated mirror. The gold actually helps it to reflect infrared light really well, but it's also beautiful in a way that's maybe not typical for scientific hardware. I've definitely heard other telescopes described as something only an engineer could love, but I thought this telescope was something that artists could love, both because of its beauty and because of the inspirational things it's going to show us. So back in 2016, when the telescope was at Goddard, I organized an event where we invited artists to apply to come see our telescope in person and sit in front of it, talk to mission experts, and be inspired to create art. And as it turned out, happily, the telescope did inspire art, and a great deal of it. We actually had an exhibit of that art at the NASA Goddard Visitor Center in 2017, and some of our artists just kept right on creating work inspired by our mission. The art that you saw in the Earth Gallery when you entered tonight is art that was created by those exhibit artists, and we have a couple of them here tonight, including Brandi Smart and Jedidiah Dore. So if you haven't had a chance to chat with them, please feel free after Elaine's talk to ask any questions, and they're here. So that's really, really cool. And I also wanted to introduce another one of those artists, Ashley Zelinskie, because it was she and her team from Metaxu that created this beautiful installation that we're in right now. Ashley, are you there? Do you want to tell us about your original art for our exhibit and then what you created here? Ashley, can you hear me? I know she's having some audio problems. There she is.
Hello, everyone. Welcome to the space. This is Unfolding the Universe, and this is the part of the exhibition that I created. I was lucky enough to get to see the James Webb Space Telescope in person, and was inspired to create the sculpture that you're seeing behind you with the hands pushing through the mirrors of the James Webb Space Telescope. They are the hands and arms of a few of the scientists on the project, and they're wrapped in the metrics that were used to build the telescope. So that sculpture actually exists in real life and was displayed at NASA Goddard a few years ago. But with all this COVID stuff, we decided to do this VR space and make a VR experience. So I was able to actually take the 3D models from creating that sculpture and implement it here in the space, and got to animate it. So it has like the arms are actually floating up out of it. And then I wanted to make this special and a commemoration of the launch. So I was able to talk to lots of the scientists, engineers, and administrators that worked on the James Webb Space Telescope project. And I wanted to get to know them, their part in, what they were doing for the James Webb, what inspired them, what did they think of all these new developments in technology, what was out there in the universe, what are they searching for. So if you walk around the gallery space, you'll actually see these portraiture of all of these scientists, engineers, and administrators, and you can actually walk up to them and hear little snippets of those interviews that I did with them. And tonight we're lucky enough to be with Elaine Stewart, who allowed me to interview her and draw her portrait and put her in this space, in this VR world. But yeah, she's here tonight with us live, and she's going to tell us more about her experience with the James Webb Space Telescope. So I'll turn it back over to Maggie, and she can intro Elaine. Thanks for coming, everyone.
Great. I believe I'm still on the stage, so you should still be able to hear me. I did want to add one thing, that since that art event and exhibit, that we've had 2 different public art campaigns where you can send us art inspired by the science and engineering of the mission, and we might share it in our web gallery or on our social media. So if any of you out there are artists, please send us your art. You can use hashtag #UnfoldTheUniverse on social media. Next, I want to introduce our special guest, Elaine Stewart, who's an early career engineer who worked on contamination control, that is, making sure our telescope hardware is clean and pristine while it was being built. And she's going to give us an overview about the telescope and her experience working on it. So please welcome Elaine.
Thank you so much, Maggie. Just want to do a quick audio check. Am I able to be heard okay by people in the VR space? Slide, please.
Loud and clear.
Yes, so that's the next slide. And also, Elaine, could you need to watch the public? Or keep moving between one and the other?
This is fine. Yes, this would work well. Okay, so there we go. Thank you. Okay, now I've actually had the privilege of working on the Webb telescope for the past 5 years. So I'm going to tell you all about the telescope, and I can't wait. All right, next slide, please. Now, the Webb telescope is a combination of many innovative and powerful new technologies that will make our observations possible. So some of the examples of these new technologies that we implemented on the telescope include the specialized optics that we actually use to align the mirrors. We are currently working on this process now that we are actually up in L2 after our launch. We also have detectors that can capture and separate light from hundreds of sources at once, and thermal control systems. Now, all of these subsystems working together and these new technologies make Webb the most sophisticated and complex space telescope that we have ever created. So it is a collection of movable parts. We actually call it somewhat of an origami telescope because we actually had to fold the telescope to fit inside of the rocket upon launch. We launched on an Ariane 5 rocket out of French Guiana. You'll also notice that there is, in that bottom right picture, layers of material. Now that is actually called the Sunshield, and it is the size of a tennis court. There are 5 layers that are made of a mylar material, and it actually folds up so that we were also able to fit in the rocket. It was deployed by over 139 tiny little mechanical motors called actuators, and many other components which actually allowed it to unfold and stretch into the final shape. So let's get a bit of a closer look at the mirrors. If we could go to the next slide, please. Now, here you can see on the left, there is the primary mirror for Hubble Space Telescope, and on the right, there's a primary mirror for the Webb Space Telescope. So Webb actually has a 6.6 meter diameter primary mirror, and it's very large in comparison to the Hubble mirror. Hubble mirror was around 2.4 meters in diameter. We have to have a larger mirror for Webb to capture high resolution Hubble-like details, but in infrared light. Now the mirror actually also needs to be stable at very cold temperatures, around 40 K, which is why we needed to construct the mirror of beryllium. Beryllium is actually 6 times stronger than steel and 2/3 the density of aluminum. There are 18 hexagonal segments that we used on the Webb telescope primary mirror, and we are currently working on aligning those 18 segments to actually operate together as one large primary mirror. We've coated each of these segments in a very thin layer of gold, which is only about 1,000 atoms thick, and we needed the gold coating so that we could have the best reflector for infrared light. We could go to the next slide, please. On board the telescope, we have 4 different instruments: near spec, nearest, near cam, and MIRI. They're all sensitive to a range of infrared light. Now, the near-infrared spectrograph, or near spec, is one of the most versatile tools that we use for infrared spectroscopy, which actually spreads out the light to its component wavelengths just like a rainbow. This instrument is the first multi-object spectrograph known as SPACE, and it also has a microshutter array. We capture individual spectra of dozen objects at once, and then we're able to observe many distant fake galaxies with the use of this instrument. With the nearest, or the near-infrared imager and slit-lit spectrograph, we gather spectra and photograph the universe at some near-infrared wavelengths. So this instrument will actually use to study the composition of exoplanet atmospheres, observe distant galaxies, and examine bright objects that are very close together. The NIRCam is the Webb's primary imager camera. So we'll actually receive high-resolution imaging and spectroscopy for our investigations of our targets. We can actually detect light from the earliest stars and galaxies in the process of formation, and you'll also be able to track the motion of exoplanets as they orbit their star. The final instrument is called MIRI, or the Near Infrared Instrument, and it is able to take images and gather spectra. but it covers longer and redder infrared wavelengths of light. So it is the only mid-infrared instrument, and we will use this to study cooler objects, such as debris disks around stars, and they emit most of their light in the mid-infrared range. Okay, next slide, please.
How do I back out if I want to get back into this?
Now, the launch actually just occurred on Christmas Day of 2021. I was able to be present for the launch. It was an incredible experience after spending a couple of months in French Guiana. We launched it to the Lagrange point. Now, it is called, in short term, L2. It is the point where the gravity from the sun and the Earth balance. It's approximately 1.5 million kilometers, or almost a million miles away from Earth. It's around 930,000 miles away from Earth, and it is on the far side of the Earth from the sun. Now, we can't actually orbit Earth like Hubble did because we need to do these infrared observations. So the light from the sun, the moon, and the Earth would actually heat up our mirrors, and our instruments would not be able to operate at these really cold temperatures that we need them to observe these faint galaxies. Okay, next slide, please. Now we get a closer image of the Sunshield and the primary mirrors and how we are actually currently deployed and oriented at L2. So you can see that in this image, the secondary mirror is actually in its full deployed state. Now this is important because the light path actually reflects from the primary mirror to the secondary mirror and then into the instruments. This is really crucial for my role on the telescope as a contamination engineer. One of our main concerns was ensuring that the optical surfaces were as clean as possible because we needed to make sure that there would be no degradation to the images that we will get back from our targets. So if you have particulate or you have thin films, which we would call molecular contamination, they can actually distort these images. So we worked very hard and tirelessly to model and mitigate to ensure that our images would be as pristine as possible. Next slide, please. I also wanted to show, after launch, this was the unfolding sequence that the telescope performed. Now, we had to go through those origami folding mechanisms before we launched so that we could actually ship from the United States over to French Guiana and then also fit in the rocket. Now, I was actually able to travel with the telescope. The telescope was at Goddard Space Flight Center about 5-6 years ago, where they actually had the artist gallery that you just witnessed virtually in person. This was just prior to our shipment to Houston and the Johnson Space Center, where we cooled the telescope down to the temperatures it experiences at L2, and we tested to make sure that the instruments, the mirrors, everything was operating as expected. We then went from Houston to Los Angeles at Northrop Grumman, and we integrated the telescope element on top of the Sunshield. From there, we moved to French Guiana. So as you can see, for a very large telescope, there was a lot of movement that needed to happen. And the only way that we were actually able to make this possible over planes, actually shipping on a giant cargo ship to get to French Guiana, was the ability to fold the telescope and have this really unique engineering capability. Now, this launch sequence has, launch and deployment sequence has occurred since December 25th. So during that first month of space, we actually deployed, tensioned, and separated the Sunshields. We extended the secondary mirror. The primary mirror was unfolded, and now we're in the process of actually aligning and focusing the primary mirror. So you may have seen that there are actually some images that have come out from the Webb team. We are still working, and we will get around the 6-month mark our first scientific images and begin our routine science operations. Next slide, please. Now, my background is in chemical engineering, but I'm actually pursuing right now a master's in space systems engineering. So one of the challenges that exists with talking to satellites and telescopes is we need to communicate from the ground up to the hardware. So here you can see that we're actually currently operating 24 hours a day from the Space Telescope Institute, which is located in Baltimore, Maryland. It hosts the Missions Operations Center, and the engineers and scientists are able to command and control the telescope from there. The commands from the Space Telescope Institute actually travel to the Deep Space Network, or the DSN, which then gives the commands over to Webb. Webb's data will then be returned from the Deep Space Network to the Space Telescope Institute, and then the scientists and engineers working there are actually able to take that data, process it, and they distribute it to our community.
Just follow me, I'll take you over.
Next slide, please. Now, outside of all of the incredible engineering and technological advancements that went into the telescope, it is really important to note that this would not have been possible without all of the international collaborators. So it is, from the start of the project, always been an international collaboration. In addition to the US, there are 14 countries involved in the building of the Webb telescope. I was able to work with members from ESA, or the European Space Agency, at the launch site in French Guiana. It was really a joy to be able to work alongside them for the common goal of launching the telescope. Okay, next slide, please. Now we've learned a bit about what the telescope looks like, the engineering that has gone into it, and it has all been fueled by some main science objectives. So we want to know, what was the universe like shortly after the Big Bang? What are the characteristics of universes and galaxies of those universes as they've aged over billions of years? How can we learn more about when stars form and die and that process? So if we can go to the next slide, please. Let's talk about some of the science objectives for Webb. Okay, now I know most people have heard about the Hubble telescope, as I showed you the mirror earlier. We actually have on the left here an image from Hubble. This is of what's called Eagle Nebula's Pillars of Creation. Now this image is in visible light. The middle picture is in near-infrared light, and then the Spitzer Space Telescope is shown in the far right image in mid-infrared light. Now, similarly to Spitzer, Webb will actually be able to see through the dust in regions like this, but in high resolutions, like the Hubble Space Telescope was able to do. So let's just talk a little bit about what each type of light will show. In visible light, we can actually see forming stars inside of dense areas of gas and dust. In near-infrared, light shines through, but the densest dust reveals many stars inside and around the pillars. And the mid-infrared light shows eroded pillars of gas and dust that glow with the heat from the bright young stars. Webb, with the infrared capabilities, will actually allow us to see past the dust clouds and figure out what's going on in these dense regions for the first time. So let's move on to our next science objective, which is looking at some of the first galaxies. So this galaxy that is shown here was actually observed 13.4 billion years in the past. So that's when it was observed, just 4 million years after the Big Bang. And one of Webb's main objectives will be to look at some of those first galaxies formed in our universe. We're going to talk a little bit about how on our next slide, please. The scientists will actually be looking at individual galaxies and figuring out how old each one is. So we want to study galaxies over time. By looking at the universe at different distances and eras, we know that galaxies change over time. You know, they can grow, they can run into each other, and they can even merge. So the most distant galaxies and the earliest galaxies that we've seen usually are smaller, they're less structured than those in a nearby universe. However, we haven't really been able to look at some of those earliest galaxies. That's because the universe is expanding, and when space is stretching, so does the wavelength of light from those first galaxies into infrared light. Again, that leads us back to why we have these infrared instruments to do our science observations. So we were able to look at some of these early galaxies and the galaxies formed just after, so we can understand how they were formed and look at dust stars and the formation over time. Next slide, please. Now this image is actually one in visible light and one in infrared light for the same area. It is called the Carina Nebula. So the visible light shows scorching radiation and fast winds from new stars and how they are shaping and compressing the pillar, causing these new stars to form. But we don't really see the new forming stars because of the dust that is covering it. The near-infrared light reveals the stars behind the gaseous, dusty veil that we see. And we can actually see a bit more in the infrared image. With our telescope, the Webb telescope, we'll actually be able to see even more details of these star-forming regions. We'll be able to learn more about the physical and chemical properties of our stellar and planetary systems. Which brings me on to the next slide, please. And examining our own solar system's planets. We will gather data about Mars, Jupiter, Saturn, Uranus, Neptune, and really understand a bit more about our planets in the solar system. We want to learn more about Mars' atmosphere, look at some of the cloud structures on Jupiter, Saturn, and look at the seasonal weather and climate on gas planets and their moons. Next slide, please. We will also be able to find new distant planets. Now, there have been past missions and past observatories that are already studying distant planets. But the advantage of Webb is that when warm planets glow brightly in infrared light, their host stars usually don't shine as brightly in those wavelengths. So their innate contrast means that infrared light is the ideal wavelength to observe these planets. Where we are located at L2 and with our large primary mirror, we're able to capture longer infrared wavelengths of light in a high resolution for the first time. So we're able to take very sharp and very fast images to spot smaller planets than some other telescopes and missions from the past. This image here is actually showing a coronagraph. So most of the light of the star at the center is blocked by an instrument known as a coronagraph, making it possible to detect 4 planets here. And if we go on to the next slide, please. So just to summarize, we have 4 main science objectives that we want to accomplish with the telescope. We're going to capture light from the first generation of galaxies in the universe, look at mapping how galaxies change over time, investigate how stars form, live, and die, and look into distant worlds. We're approaching the 6-month mark after the launch. We will actually begin our science mission and our science observations that will be shared with everyone. I'm really excited and happy at this time to answer any questions. If you want to move to the next slide, please. Okay, thank you so much. Ashley and Maggie, feel free to send over any questions.
Yeah, absolutely. I'm pretty Q&A, just hold the question for a second. If Pierre's there, if he wants to come up and introduce himself, let's do that first.
Yes, hi, hello. I'm joining you on stage. I mean, first I have to apologize. It seems that we are having some issue with sound, so I know we are crackling, and it's not the best experience of sound. Hopefully, people can understand everyone all right. It's a good habit to mute yourself if you're not talking. So I think it's all right when we are muted. Just a quick word on me. So I'm Pierre. I'm from Metaxu Studio, and we are responsible for this environment and this kind of production on Mozilla hubs. So yeah, our background is in architecture, and we obviously are producing more virtual architecture for this kind of event, and we're exploring what's possible to how we can use our knowledge of architect to create those spatial experience on the metaverse and online. So that's what we do. So if you have any question on that, please reach out to me. Otherwise, I think it's much more interesting to hear about Q&A, your questions, and Elaine's answers.
Hi. Okay. So let's go first for a question from YouTube. So Andres asks, Elaine, what science targets are you most looking forward to?
I actually think the science objectives that I'm most looking forward to are part of the early release science program. NASA actually has a program where anyone can apply for science observation time in these first months that we will actually be utilizing the telescope. So they have selected targets that they will be observing, and then all of this information will become public. It'll be really interesting to see which target observations, professors, people around the world, different universities, anyone could apply to this program. So I'm really interested to see what targets they've picked and what we can learn from those targets. This information will really fuel future missions that we pick at NASA, and in general, it will shape our understanding of space.
Awesome. So I know that. Oops, let me lower my volume so I'm back here. I know that you actually participated in a science proposal, even though you're really an engineer. Do you want to tell us a little bit more about that experience?
Yes, absolutely. In my undergraduate research, I actually investigated submitting one of these early release science proposals for looking at ultra-cool brown dwarfs. And the process was really interesting. They create tools for each of the 4 instruments that I showed you. So NearSpec, NIRI, NearCam. You can actually upload spectra from your target of observation. So I was looking at ultra-cool brown dwarfs and trying to figure out how long I would need to observe this target, what kind of information could I learn from it, and what capabilities actually existed on the Webb telescope. So it was really interesting to be able to work directly on the flight hardware while I was at Goddard, but then be able to investigate the science capabilities through these tools that were created for the proposal process.
So how did you go from, working on science to becoming an engineer? I mean, I'm sure you have kind of a love of both things, but, what inspired you to want to go into engineering for a career? And how did you get started at NASA?
Absolutely. I actually studied chemical engineering, and I found that this discipline was very versatile, but I applied to an internship at the Kennedy Space Center and spent my first summer after freshman year actually looking at a payload that was going to study lunar soil and the constituents found in lunar soil. I really had a love for space, and I wanted to continue working in this field, so I applied to the Pathways program, which is basically a co-op at NASA Goddard Space Flight Center, and was able to start my career while still pursuing my chemical engineering degree. So I actually started to work on the Webb telescope while I was still studying in school, and was able to travel and support during my summers between semesters.
It's amazing that you got a chance to work on such an incredible project so early in your career. It's really amazing. You also got to be pretty hands-on with the telescope. What was your involvement with that? I know, again, you talked about your work on contamination control. How does that work? Like, is it a very hands-on job? Is it computers? Like, tell us about your job.
Okay, so my job day to day varies. I spent a lot of time traveling to support the mission, which involved a lot of hands-on work with the telescope. And it was really rewarding. I learned a lot about flight hardware. I was very impressed by the ground support equipment that we utilized for the telescope. You saw images of the Sunshield deployed and tensioned into 5 layers while we were actually still in California and here on Earth. Something that I didn't entirely appreciate before entering into the space industry was that when you deploy a telescope or anything as though you're trying to deploy it in space, you actually need to offload because there's no gravity in space. So the ground support equipment was state-of-the-art just so that we could safely deploy every component, but especially the Sunshield on the telescope. So there is lots of equipment that never actually even made it up into space, but was really amazing to support our operations. And one of the most important contamination aspects is the idea of cross-contamination. So even if there's equipment that isn't going up into space, but it is touching flight hardware, we have to ensure that it is to the proper cleanliness, which involves looking at the particulates or the molecular contamination that might be on it, performing sampling and analysis. We do a lot of material compatibility work. When I mentioned the testing that we conducted in Houston at Johnson Space Center, every material that goes into that vacuum chamber, we need to make sure it's compatible in a space environment because we don't want something that has a high outgassing. Like kind of that new car smell is a good analogy to use. We don't want something with high outgassing to be near our optics and actually, deposit on the mirror or affect those images. Okay. So we've screened every material that we're utilizing to ensure the cleanliness and safety of the hardware.
But otherwise, I'm back.
Sorry about that. Go ahead, Elaine.
So yes, I was able to work directly hands-on. There was some hardware, some of the sensitive surfaces that we had specialty cleaning methods for. We also were monitoring the coatings. It's a different combination of coatings that we're utilizing, whether we want to absorb or emit heat. So if you want to absorb it, then you're using a black coating. If you want to emit it and you want to keep the heat away, then you're using a white coating. And so we actually have to monitor while we were going through the integration and testing process to make sure that the coatings were still adhered properly and make sure that they would function and maintain thermal control as expected once we launched the telescope.
So, I want to hear about your experiences on launch, but, you're talking about the Sunshield and, having to use ground support equipment to help offset the gravity. Like, how did you feel watching the telescope deploy in space? Like, what was that experience like for you?
I was able to witness the first deployment of the solar array while I was still actually at the launch site and watching with my peers and our colleagues from the European Space Agency. It was the best Christmas gift I could have asked for. It was really an amazing experience to move from seeing the rocket on the pad, a successful launch, and then about 25-30 minutes in, we saw the detachment from the rocket and the first deployment of the solar array. It was really incredible to witness that and then follow along in the weeks after. There were updates constantly about the state of the telescope, what was deployed, what was coming up next, and it was really great to, be able to share that with my coworkers and people from the public that were excited about the telescope and wanted to hear and learn more on it.
So So we actually got a question from YouTube from Rob P. What's next for you now that Webb is launched and deployed? Are you still working on the project? Have you moved on to other things?
I actually still am supporting Webb in some capacity. We don't have one contamination engineer that is required to always be at the Space Telescope Institute, but we are involved because we're very interested in the temperatures that we're operating at. One of the contamination aspects that we pay attention to is where the hot surfaces are versus where the cold surfaces are, because the contamination will mitigate towards those cold surfaces. So we really want to be up to date with that information. But I've actually moved on to a new project. It is called the Roman Space Telescope. It is also at Goddard Space Flight Center, and I'm really excited to work on the optical telescope assembly for the Roman Space Telescope. And as I mentioned, I'm pursuing my master's in space systems engineering, which really just gives me a great overview about how all the subsystems work together to create these amazing missions and satellites that I am so fortunate to work on.
So I do want to talk about the launch. I'm jumping around a little bit, but you went to the launch site actually more than once, correct? And you were there for the launch. Tell us about that.
Yes, so I had the privilege of starting in September of 2021. I started traveling down to the launch site, and I made 3 different trips out to French Guiana. Now, it was an incredible experience. I made some connections with the European Space Agency co-workers that I still stay in contact with. And it was really great to see that, you know, we were working towards one main goal of we wanted to launch the telescope, and we wanted to have, you know, just an incredible launch campaign together working on this. I was able to experience the culture in French Guiana. It was very nice in December when it was cold and snowing here. I was enjoying some very nice warm weather. We saw a lot of incredible wildlife. I got to drive by a sloth every day on my way to work, and that was amazing. So I would say that overall I enjoyed the culture in French Guiana. I enjoyed working with our counterparts there. And this is my first launch campaign, which I will really just hold near and dear to my heart for however many more missions I support, because I learned so much during the duration of it. The main operations at any launch campaign first involves receiving of the telescope, which was a huge ordeal for the Webb telescope arrival, because it was coming off of a barge. We had to take it out of basically a mini clean room. While we transported the telescope, the humidity and temperature were monitored. We took the telescope out, inspected, everything looked great, and then we went into some of our final checkouts and integration. And from there, we actually moved over to fueling. So we moved from one facility to the next to support the fueling operations. These were specially trained technicians that actually put the fuel into the telescope. And then we moved over to the building where the rocket was. So I actually got to be next to the rocket. I got to access platforms for the rocket up on like the 14th level and look down and see the whole structure and the telescope on top. It was absolutely incredible, and you know, I'm really grateful that I got to witness each stage of the launch campaign, and will carry that information forward throughout my career.
That's so exciting. I'm so excited for you that, again, that you know have gotten to experience this. I'm very jealous about the sloths as well. What is your favorite memory from being on this project? Like, what will you take with you forward?
I think my favorite memory would have to be just the connection that I have with my co-workers now. I am relatively new to the project in comparison to some of my colleagues that support it. Some people have been on the mission for double or triple the amount of time that I supported it, but I've always felt very respected and welcomed. to the mission. The Webb project really valued teamwork. They valued new ideas. I felt as a new engineer, I was really able to grow, learn from the expertise of the past, but be able to bring new thoughts to the table. So I think I'm really going to miss the environment that I was able to work on this telescope on, and the connections and the people that I've met throughout it. Even now at Goddard, when I run into some of those coworkers from the launch campaign, you know, we're constantly reminiscing on those moments where we supported in different facilities from Houston to California to French Guiana, at Goddard in Maryland, and you know, we really have a bond of being excited about these first images from the telescope and knowing all the people that contributed to the success of it.
Thank you. I see we actually have a science question in the chat on YouTube that I think I might field if you don't mind. Tracy is asking how we determine the origin or the location of the Big Bang within the universe. That's an interesting question because, you know, the name Big Bang sort of implies something like a firecracker that has a center point and explodes from it and spreads out from a central point. But interestingly, the Big Bang is actually not at all like that. The Big Bang is a process happening in time everywhere. There is no center to the universe. There was no center to the Big Bang. So there isn't really an origin or a location point from the Big Bang. It just happened everywhere at once. It's kind of hard to wrap your head around the whole concept of the universe not having a center, but you know, when we see how the universe expands and galaxies move away from each other, there is no center that everything is moving from. Are there any more engineering questions from either YouTube? You can put them in the chat. Those of you in the VR space, do any of you have questions you'd like to ask? You can feel free. You can type them in the chat. Those of you in the VR space, do any of you have questions you'd like to ask? If not, we're going to feel free. We're going to thank Elaine for her time and for her presentation and sharing her experience working on this amazing project. We're going to thank Elaine for her time. One last chance for any questions. Okay, so some of us will be sticking around after, so you should all feel welcome to come up and ask any questions that you have to the artists here, to Elaine. Also, please feel free to explore this gallery. It will be open for a little while longer. If you look across, you'll see some purple figures of people. Those are the scientists and engineers that Ashley interviewed, and you can interact with those and listen to the interviews that Ashley did with them. So those are interactive. Please feel free to look there. And just look around the space. And thank you all so much for coming. I'm so sorry we had some sound issues. We're still really experimenting with this whole process. It's very new to all of us, but I think it's such a fun way to talk about our project. It's just a little bit different. So, and you know, we just love celebrating art also. Thank you all so much for being here. Thank you, Elaine, and thank you to Metaxu and Ashley and everyone. So thank you so much. Thank you all so much for being here. Thank you, Elaine, and thank you to Metaxu and Ashley and everyone. So thank you so much.
Wonderful.